OK, here's another strategy. This one's pretty cool. It's called a honeypot. And here, we'll take the idea of stack canaries and extend them to defend systems in general. So what's a honeypot? It's a system with no real purpose, just like the stack canary. The stack canary data wasn't something we actually cared about. We weren't computing anything with those random numbers. It's just some sacrificial system. It doesn't have a real purpose. Therefore, nobody legitimate should ever access the honeypot. There is no reason to access the system. It is just sitting there with no purpose. Therefore, if you notice somebody accessing the system, that's a good sign that they're an attacker. Nobody legitimate should ever be touching this. So if someone touches it, they must be an intruder. Similarly, in stack canaries, no one's supposed to touch that value. So if someone overwrites it, they must be an attacker. That's the idea behind the honeypot. Now, there could be false positives. Somebody legitimate might accidentally try to access this system. So it's not perfect, but it can help you try and detect attackers. So here are a bunch of examples. One real-life example of honeypots is in hospitals. There's rules that employees aren't supposed to read confidential patient records. So if you're a nurse, you're not supposed to open somebody else's file and read about their case. That's violating their privacy. So maybe you as the hospital director want to catch malicious employees who are reading patient records that they're not supposed to. So maybe what you can do is make a honeypot record. It's a fake record that's not real, so no one is supposed to actually access it, and put a really scandalous celebrity name on it. So put some name that's in the news that someone might want to access. And if an employee is malicious, they might try to access that record, and you would catch them. Nobody is supposed to access it, but the employee accessed it, so now they're in trouble. Every semester we try to pick a scandalous celebrity to put here. I don't know who it would be this year. Last year was Elon. I don't know if that's still true. OK. So a second example is an unsecured Bitcoin wallet. So if you want to tempt malicious users into accessing the honeypot, what you could do is maybe just leave some money on that malicious or honeypot system. So if the honeypot system is just sitting there and not really doing anything, attackers might not be tempted to access it. So one way to lure attackers into actually accessing that honeypot is to just put a little bit of money on it. So maybe using Bitcoin, which is something we'll talk about later. It's an online money system. Maybe you'll leave $20 of Bitcoin on that honeypot system. And if an attacker breaks into your system and they're looking around at all the computers, they might notice the $20 and go and pick it up. And if they go pick up the $20, then you know that someone is attacking your system. So just by spending $20 and leaving it there for someone to steal, you might be defending much more expensive systems elsewhere. Now, a third example is a spam trap. So if you've ever wondered how modern email clients are so good at capturing spam, what you could do is make a new spam or a new email address and don't give it to anybody. So this is not an email address that an actual human uses. You don't use it to send mail. You're not asking people to send mail to this email address. So if this email address that nobody is actually using gets an email, that's probably spam, because nobody was supposed to send mail there, but you still got the email. That could be a spam email that nobody is asking for. So those are some examples of honeypots. And here are the trade-offs of honeypots. Once again, you can detect attacks that are brand new. Even if the way they got into the system is brand new, if they access your honeypot, you still catch them. Something very cool about honeypots is that once the attacker breaks into your system, you can actually track them. So as they're interacting with your honeypot to try and steal the money or something, you can analyze what they're doing and try and learn about who they are, what their goals are. So as they're accessing your honeypot, you can spy on them and see what they're doing. Also, like in the Bitcoin case, if you leave some money out, you can distract the attacker from legitimate targets. So give them that $20, they can take it, and that can help you defend $1,000 or $1 million systems that you don't want the attacker to touch. Now, here are some drawbacks. One is that you have to trick the attacker into accessing the honeypot. If it's not a convincing honeypot, there's no reason for the attacker to go and access it. So you might want to put some money on it or build a fake system or a fake celebrity record that makes people want to access that celebrity record, and that can take some work. That said, there are some cases where this drawback isn't too big of a deal. For example, if you're trying to detect spam, you don't have to make that email any more convincing. The spam bots will probably send emails to your honeypot anyway. So those are some trade-offs, and that's the idea behind honeypots.